Welcome to the Bill Nile the Science Guy show. Today we'll be talking about acids and bases. There's two definitions for acids and bases, the Arrhenius model and the Bronsted-Lowry model. In the Arrhenius model, anything that produces hydrogen ions is an acid in an aqueous solution, and anything that produces hydroxide ions in an aqueous solution is a base. An aqueous solution is anything where the main solvent is water. The Bronsted-Lowry model defines anything that produces hydrogen ions as an acid, and anything that accepts those hydrogen ions to be a base. There's two types of acids, binary acids and conjugate acids. Binary acids are made up of two elements, hydrogen and one other element. In order to name these elements, first, you add hydro to the front. Secondly, you take the second element and take the anion name and use that as the suffix. Now, we have chlorine. That means it's chloride. Now, we change the ide in chloride to chloric, and then we add acid. This is where we get hydrochloric acid. Now, the second type of acid is referred to as conjugate acids. These acids normally involve polyatomic ions, such as sulfate or hypochlorite. For example, we have sulfuric acid. Now, since it's sulfate, we change it to ic. But in hypochlorous acid, which has chlorite, we change the ite to us. We get hypochlorous acid. A rule when naming elements that have sulfur or phosphate, you leave sulfur as sulfur, so you have sulfurous acid and sulfuric acid, and then phosphorus, you get phosphoric acid and phosphorus acid. Now, you have strong acids and bases and weak acids and bases. Strong acids are any type of acid or base that completely dissociate in an aqueous solution. That means that the two components, such as hydrogen and chlorine, completely separate in water. Now, a weak acid and base does not completely dissociate in water, such as hydrofluoric acid. You will have some compounds that will dissociate, and then you'll have some that will stay the same, stay together. pH is a measure of hydrogen ion concentration in an aqueous solution. pOH is a measure of hydroxide ion concentration in an aqueous solution. Both of these are measured on a scale of 1 to 14, 7 being neutral. In pH, 1 is considered acidic, and in pOH, 14 is considered acidic, vice versa. So that means 14 on the pH scale is basic, and 1 on the pOH scale is basic. To solve for pH or pOH, we simply use negative log of the molarity. Molarity is a measure of concentration. For example, if we have 0.0025 molarity of hydrochloric acid, we take negative log 0.0025, and that equals 0.26 pH. Now, to solve for concentration, we simply use 10 raised to the negative pH or pOH. Example, hydrochloric acid has a pH of 2.6. 10 raised to the negative 2.6 equals 0.0025 molarity. You can use 14 minus pH, solve for pOH, or 14 minus pOH to equal pH to solve for each concentration, because they're inverse of each other. Well, I would like to thank all of you for tuning in to this episode of Bill Nile the Science Guy, and please tune in next week. Thank you.